Okay, so in a chemical reaction, we begin with one or more separate substances. We combine them in a multitude of different environments, in water, under pressure, with heat. We can combine them in a ton of different ways, but the result will be something new, something completely different. Okay, so one or more different substances. Chemical reactions and chemical equations are made up of two distinct parts. Can anyone name those two parts of a reaction?
A reactant and product.
Yeah, good. A product and a reactant. Reactant and product. Which goes on which side of the equation?
The reactant goes on the left.
Yeah, good. The reactants go first. Okay, so reactants are the original substances, or what we start with. Okay, so chemical equations are typically written like this. I'm just going to use A, B, C, D for our different chemicals here. But if we begin with substance A and some substance B, we begin with two of these substances here. We put an arrow into our chemical equation to show that a reaction has taken place, and we end up with C and D. This is what a chemical reaction typically looks like. This is the base kind of formula for a chemical reaction. So these would be the reactants, which would make these on the right side what? The products. Okay. So reactants are what we start with. Products are what is made. Okay, the new substance. What are some indicators to show us that a reaction has taken place? Foam. Okay, good. Yeah? Heat. So if you put two things together, they start foaming, you know a reaction's taken place. If something gives off heat, a reaction has taken place. There's a couple other indicators. Yeah, Carson? Light. Good. Okay, some reactions produce both heat and light as forms of energy, or could be one or the other, okay? A transfer in energy like that is a good indicator that a reaction has taken place. Okay, production of a gas, okay, if it starts smoking, if it starts letting off some new chemical in the form of a gas, that's a pretty good indicator that a reaction has taken place. Okay, which is what we were talking about with the foam, okay? Those bubbles make that foam. Those bubbles of that new gas will make a foam or some kind of bubbly substance. Okay? There's a couple more. Formation of what we call a precipitate. Does anyone have a guess what a precipitate is?
Liquid.
What?
Liquid.
Not a liquid. What's our last phase of matter? Yeah, a solid. Okay. So precipitate is if a solid appears after you mix two chemicals together. Solids may drop out. That's a really good indicator that a reaction has taken place. So our last indicator is a color change. Okay, if you combine two things and they form a new color, that must mean that a reaction has taken place of some kind. All right, so in a chemical reaction, we must have an equation that goes along with it. Okay, the chemical equation I showed you earlier in the most basic form is just A plus B yields C and D. Okay, that's just a very basic form of a chemical equation. These, of course, will all be substituted with different compounds or elements. Okay, so when we write a chemical equation, we have to include all of our known facts about that reaction, okay, or about that system. Okay, and what I mean by this is that we can't leave any substances out. Okay, all products and all reactants have to be listed in that chemical equation somewhere, okay, on either side. If it lets off just a little bit of oxygen in the reaction, that means we've got to include that oxygen gas in our equation. We can't leave it out just if it's a little bit. Okay, or we can't leave out one of our reactants if we only used a tiny bit of it. We've got to include every single thing going in and every single thing coming out. Okay, in our chemical equations, it's essential that we have the correct chemical formulas. Okay, that's why we worked so hard in Chapter 7 with naming compounds. That's going to come right back this chapter. Okay, so you need to be comfortable with naming compounds. That's why we did it so much, because it's very important. Okay, our chemical formulas have to be 100% correct or our equations will not balance. Okay? That's why we worked so long and so hard on them in chapter 7. Okay? Tell me what the law of conservation of mass means. Yeah, Kelsey? Yeah, exactly. Mass cannot be created or destroyed. That's for the entire universe. That's for individual chemical reactions. Okay, it's both. So within a chemical reaction, we have to have atoms equal each other on both sides. Okay, so atoms can either be created or destroyed. That means the same number of atoms of each element must appear on both the reactant side and the product side. Okay, that's what we call a balanced chemical equation, is when both the number of atoms are equal on the reactant side and the product side, and that's what we're going to learn how to do today. Okay.